In this lecture, we are going to be continuing talking about chapter 11. We are going to be introducing the idea that alkanes can also be cyclic, and we're going to be talking specifically about structural isomers. So, as I just mentioned, when it comes to alkanes, we can have them in cyclic form. Understand that cyclic alkanes are going to have the general chemical formula CnH2n. So what that means is that in order to have a cyclic alkane, it's going to contain 2 less hydrogens compared to the straight chain alkane. Now, understand that the only cyclic alkanes that you guys need to be familiar with in this course are going to be the ones that have 3 carbons in the chain, 4 carbons in the chain, 5 carbons in the chain, and 6 carbons in the chain. There are going to be cyclic alkanes that are larger than that, but we are not going to be practicing or doing examples of them. So, that being said, when it comes to the condensed formula for these alkanes, or cyclic alkanes, as you can see, they are given by the top row of our figure. When it comes to the skeletal formula for these alkanes, as you can see, they take some geometrical shapes. When we're writing the names of these cyclic alkanes, the prefix cyclo is going to be utilized for each of them. So, as you can see, if we deal with the one that has 3 carbons, that's going to be cyclopropane. The one that has 4 carbons is going to be cyclobutane. The one that has 5 carbons is cyclopentane. And the one that has 6 carbons is going to be cyclohexane. When we are naming alkanes with substituents, understand that when you have one substituent attached to the cyclic alkanes, no number is required. All you have to do is write the name of the substituent, the name of the cyclic alkane, and you're done. So for example, the figure or the structure that we have in the bottom, which I'm highlighting it by putting in a green box, that has a hexagon. In that hexagon, which I'm going to highlight in blue, represents the cyclohexane. The CH2CH3 is the ethyl group. So naming cyclic alkanes with one substituent is fairly easy. Now, when we are naming cyclic alkanes with multiple substituents, we have to take into account that there are going to be different rules when we have 2 substituents or if we have 3 or more substituents. As you can see, if 2 substituents are going to be present in our cyclic alkane, we're going to be numbering the ring from the substituent of lower alphabetical order. In the case that we have 3 or more substituents, we're going to be numbering the ring to give them the lowest set of numbers, and then we're going to list those substituents in alphabetical order. So let's go through an example. So here in this molecule, we have 3 substituents in the molecule. We have, I'm going to highlight them in magenta. We have a CH3, a CH3, and we have a CH2CH3. So the CH3s are going to be my methyl groups. My CH2CH3, let me just recolor it and give it a different color. I'm going to do it in neon green. That CH2CH3 is going to be my ethyl group. Now, One of the things is that, remember, we need to put these substituents in alphabetical order. I'm going to write a note. When writing substituents in alphabetical order, the prefix for multiple substituents meaning that di, tri, tetra is not considered. So in the molecule that we have in our example, we have 3 substituents. We have to give them the lowest sequential numbers. And as you can see here, our dimethyl is going to be on carbon 1, our ethyl is going to be on carbon 3, and the full name for this molecule is going to be 3-ethyl. So 3-ethyl-1,1-dimethyl cyclohexane. Let's do some examples in which we're going from structure to name and even from name to structure. So for these problems, I'm going to do the first 2 molecules when it comes to the ones that we have in Part E on our worksheet. Okay, so as you can see, here we have a triangle. A triangle is going to have 3 carbons. Carbon 1, carbon 2, carbon 3. So that molecule, the longest carbon chain, which is going to be the cyclic alkane, it is called cyclopropane. Because we only have 1 substituent, which I'm going to highlight in green, that, because it's a line and it contains only 1 carbon, that is going to be a methyl group. So the name of that compound is methyl cyclopropane. Now, if we look at the bottom molecule, it looks like a square. Inside that square, I'm going to highlight the atoms. Carbon 1, carbon 2, carbon 3, carbon 4. So having a square is going to have 4 carbons. So this is cyclobutane. And this cyclobutane has 2 substituents. I'm going to highlight them in green. It has a carbon here, which is called a methyl group. And on the other side is going to have 1, 2, 3 carbons. And because we are attached to the cyclic system through the middle carbon, that is called an isopropyl group. Okay? When we are alphabetizing this, okay, remember, if we have 2 substituents, we have to give the priority or the first carbon to the one that comes first alphabetically. So isopropyl will come in alphabetically first. I'm going to number the carbons inside the ring. So this is carbon 1, this is carbon 2, 3, 4. So when we're writing the name of this compound, it's going to be 1-isopropyl 2 methyl cyclobutane. Make sure that you practice the other examples in the worksheet. Let's now go through, if I'm given the name, can I draw these molecules? And for this, I'm going to do Roman numeral 1 and Roman numeral 2. So I'm going to be writing the condensed formula and the skeletal formula for them. So when I look at the name, I have cyclobutane. So that means that I'm going to have 4 carbons on a row attached to one another. So I'm going to have carbon 1, carbon 2, carbon 3, carbon 4, and they're all attached to one another in a square. Okay? Now, here we're going to have a propyl group attached to this, which means that I'm going to be attaching a CH2 to a CH2 to a CH3. It doesn't matter the carbon that I select, because since we have only one substituent, you can select any of the carbons in that cyclobutane. So let's say that, for example, because of space, I'm going to I'm going to do the one in the corner, and then because I have a propyl group, then I'm going to be writing CH2, CH2, CH3. Then, because I'm talking about the condensed structure for this molecule, I'm going to include the hydrogens. So the first carbon atom to the top left corner has 2 bonds. So it will be receiving 2 hydrogens. The bottom left corner carbon is attached to 2 atoms, so it's going to be receiving 2 hydrogens. The bottom right corner carbon, it has 2 bonds, so it's going to be receiving 2 hydrogens. And the one that contains the propyl group, because it's attached to 3 atoms, only receives 1 hydrogen. Okay? If I do the skeletal structure for this molecule, then I'm going to write the square. And then I'm going to draw the propyl group, which is going to be carbon 1, carbon 2, carbon 3. Okay? So that is the skeletal structure. Let's do the next one. 1,3-dimethyl cyclohexane. So if I have a cyclohexane, the cyclohexane is going to look like a hexagon. Okay? Then understand that I can pick anywhere in this hexagon to be carbon 1 and carbon 3. Okay? So let's assume, and then I'm just doing it for numbering purposes, that I say that I'm going to number this 1, 2, 3, 4, 5, 6. You can start anywhere you want. So when it comes to this, then I'm going to write my methyl groups. So on carbon 1, I have a CH3. On carbon 3, I have another CH3, because that's what methyl groups are. Now I'm going to introduce the hydrogens that are needed for this system. So carbon 1 and carbon 3 are attached to 3 atoms, so they are just going to receive 1 hydrogen. Carbon 2, 4, 5, and 6 are attached to 2 atoms, so all of them are going to receive 2 hydrogens in order to complete the octet of the carbon atoms. If I draw the skeletal structure for this molecule, I'm going to draw a hexagon. Okay? And I'm going to do a line for that methyl group, and then another line for that methyl group. As you can see, I represented in dots those CH3s. So this CH3 and this CH3 are basically living right there. The next topic that we need to discuss when it comes to chapter 11 is structural isomers. When it comes to structural isomers, as you can see, the definition is these are going to be 2 structures that when we compare them, they're going to have the same molecular formula, but the atoms are going to be arranged differently. Okay? So as you can see here, both molecules, butane and 2-methylpropane are going to have the same chemical formula, C4H10. So if we compare each of them, or if we compare them to each other, they are known to be structural isomers of each other. So to explore more the concept of structural isomers, we are going to go over a few of the problems that we have on Part D in our worksheet. So when it comes to this, to do these problems, these are the steps that you need to follow. Number 1, determine the chemical formula for both compounds. Number 2, you're going to, so far, you can determine if you can, because there's going to be some functional groups here that you can name. If possible, determine name. If you cannot determine name, then determine if the attachment of atoms is the same or different. Okay, so to do these problems, I'm going to do specifically letter A, letter D, and letter G. Our choices is these are going to be either identical molecules, they're going to be isomers, in this case, structural isomers, or they're going to be completely different compounds. So those are our 3 choices. So if we look at the structural formula for each one of the 2 molecules on A, they both have 2 carbons, 6 hydrogens. They have the same chemical formula. Here we can already determine what is going to be the name of these compounds. Both compounds are going to be ethane. So when it comes to this, because each of them have the same name, they are going to be identical compounds. If we look at letter D, on letter D, if we count the number of carbons and hydrogens, we see that we have C3H6 on both compounds. Then here, so far, you guys can only name the second compound, which is cyclopropane. The first compound, we're going to be dealing with it in the next video. So now, the first molecule, as you can see, is going to have a different attachment of atoms. So that means that the relationship between the molecule on the left and the molecule on the right is going to be structural isomers. Lastly, on letter G, as you can see, we have in the following molecule 2 carbons. When it comes to the number of hydrogens, we have 3 plus 2, that's 5, plus 2 more, that's 7, and we have a nitrogen. In the next molecule, we have 2 carbons, we have 3 plus 3 plus 1, 7 hydrogens, and we have 1 nitrogen. So far, we're going to be discussing later in the semester the name of the molecule. But so far, we can see that the attachment of the atoms between the 2 molecules, it is different because the one on the left has a CH3 attached to a CH2, attached to an NH2, And the one that is on column number 2, it has an N attached to a hydrogen, attached to a CH3, attached to a CH3. That means that the relationship between these two molecules is going to be structural isomers.